We're asked to graph the hyperbola given 9x squared minus 4y squared equals 36. We'll begin by writing the equation in standard form. Because we have the x squared part minus the y squared part, we'll be writing the equation in this first form, where again we have the square of the x part minus the square of the y part equals 1. This indicates we will have a horizontal transverse axis, and therefore the hyperbola will open to the left and right as pictured below. But again, we first need to have the right side equal to 1, so we'll divide both sides of the equation by 36. More specifically on the left, we'll divide each term by 36, which gives us 9x squared divided by 36 minus 4y squared divided by 36 equals 36 divided by 36. And now we simplify. 36 is equal to 4 times 9. Simplifying, 9 divided by 9 simplifies to 1, and 4 divided by 4 simplifies to 1, giving us x squared divided by 4 minus y squared divided by 9 equals 1. Going back to the standard form for the equation of hyperbola, again, because we have the x squared part minus the y squared part equals 1, we have a horizontal transverse axis, which indicates the hyperbola opens to the left and right. H comma k is the center, which you can see in our case, the center is 0, 0, the origin. The denominator of the x part is a squared. The denominator of the y part is b squared. This is important because the endpoints of the transverse axis are a units from the center, and the endpoints of the conjugate axis are b units from the center. So looking at the given equation, again, we know the center C is the point 0, 0. A squared is equal to 4, which indicates A equals 2. B squared equals 9, which indicates B equals 3. Now the way we're going to graph the hyperbola is we'll plot the center, determine the endpoints of the transverse and conjugate axes, and then we'll sketch the rectangle where the endpoints of the two axes are the midpoints of the four sides of the rectangle. Once we have the rectangle, we'll sketch the asymptotes, which pass through the diagonals of the rectangle, and then from there, we'll make a nice accurate graph of the hyperbola. Notice the endpoints of the transverse axis also give us the vertices of the hyperbola. So let's first plot the center, 0, 0. And because we have a horizontal transverse axis and a equals 2, the endpoints of the transverse axis are a units from the center, or 2 units from the center, which means one endpoint is 2, 0, which is also a vertex. The other endpoint is negative 2, 0, which again is also a vertex. So this is the transverse axis. And now we'll sketch the endpoints of the conjugate axis. Because b equals 3, the endpoints of the conjugate axis are 3 units above and below the center, here and here. Again, this is the conjugate axis. And now we'll sketch the rectangle where these 4 points are the midpoints of the 4 sides of the rectangle, which give us this rectangle here. And now let's sketch the asymptotes, which pass through the diagonals of the rectangle. Notice the asymptote with a positive slope has a slope of 3 halves. To find more points on the asymptote, we can go up 3 and right 2, up 3, right 2, or going back to the center, we can go down 3 and left 2 as well. Let's sketch this asymptote. And because this asymptote has a slope of 3 halves, the asymptote with a negative slope will have a slope of negative 3 halves. From the center, we can go down 3 and right 2 as many times as we need to. We can also go up 3 and left 2 as much as needed. Let's sketch the other asymptote. Because we know the two parts of the hyperbola pass through the vertex and approach the asymptotes, we can make a nice accurate graph of the hyperbola. The piece on the right looks something like this. the piece on the left looks something like this. Now I should mention, if we did want to find the two foci, we would have to determine c using the equation c squared equals a squared plus b squared, and the two foci will be c units from the center. I hope you found this helpful.